Oh, hey everyone. It's February, March the 1st. Alright, so this week is dedicated to writing the actual paper. I've been delaying it, and now finally really have to deliver. And boy, is it a slow process. I'm never a good writer. What? Hold on, let me do this again. I think I can write well, but I'm not a big fan of it. And to get into the writing mode, especially for a paper, it just takes so much effort. And this is going to be a very, very long paper, so it's going to take a lot of efforts. So we'll see how it turns out. I think I haven't even finished section 2. It's been 3 days. I haven't finished section 2 yet. We'll see. Alright, so what we have today, string compression. May have done this before. Don't remember. Oh, a lot of people hate it. Alright, array of characters. Compress it using the following algorithm. Begin with an empty string. For each group of consecutive repeating characters in chars. If the group length is 1, append s. Otherwise, append a character followed by the group's length. The compressed string should not be returned separately, but instead be stored in the input character array. Note that the group lengths that are 10 or longer will be split into multiple characters in chars. After you're done modifying, return the new length of the array. You must write on that you only use constant extra space. So in return 6, the first 6 characters of the input length should be A2, B2, C3. Okay. Return 1. Return 4. So A, B, oh Jesus, B12. All right. What do you think? Well, what I think is we just go one by one. What's the difficulty in this? We have 2 pointers, one on the front, right? Another one will go from the second one, and we'll have a count. All right. So yeah, count will be 2. The next one is not the same, and then we'll say this and 2, right? And we'll move this one here. Count become 1. So something like this. This is the initial idea. Let's see if it works. All right, so we have, I can set ij, 0 and 1. Count is 1. Now I'll put a count here. C is count, right? So that's our initial. Then we say for j in range. Ooh. Let me think. Did we go for j? Yeah, in this case, this is for j. Len chars. Then we only need I. We don't need j here. So right. And then we say if chars j is equal to chars j minus 1, right? Count plus equal 1. Else what? If they're not the same, then the count will have to be after, so we're gonna say for digits in strc, chars I plus equal 1, chars I will equal to d. All right, go back up. Okay. Now come out. Ooh. I see see what the issue. We have to do chars I shall equal to chars j minus 1, right? And then I can do I plus equal 1. I can do it inside. But, well, plus equal 1, and then we do this, blah, 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 finish. Then I need to plus equal 1. Yeah, I need to plus equal 1 anyway. So I plus equal 1 on the outside. And then C will return to 1. Count return to 1 because count is the current j. Right? And then once we're done, we'll return I. All right. Let's take a stroll. Take a stroll. So this will be returning 6. This shall return 1. Oh, it just return 1. That does not look like return 1 though. All right, we'll handle that later. This will return 4. Yeah, I think the second test case is not right. Let's compress chars. Oh, we've indexed out of range. I have worse issues here. Oh, terrible, terrible. Let's go through this again. I is the index of the first one, right? And then j is the second one. If nothing, then we shall return I plus 1 at least, right? Yeah. We shall return I plus 1. But the j, the length, right? The length. Because initially, well, we can handle that later. Let me see this. And then, in fact, I want to also test a very simple case of A and B. Right? That should be 2. No one passed. All right. So for this, I is 1, right? And then this is equal to this, so count become 2, right? And then we'll move on to this. Now this is not equal to, then we say chars I will equal to this, that's fine. And D in, well, C just one thing, so I plus equal 1, and chars this will equal to D. Okay, that's good. And then will come out I plus equal 1, so I go into the next one. Okay, so I point into here. Now B is pointing, not B, J is pointing to this as well. And then J go to this one, right? And it's equal, so C become 2 again. And J comes here. Now we do, yeah, let's see what happened here. We just print chars at every, let's see, A2, B2, C, ooh, I forgot to end it. Okay. Basically, what we need to do is we need to end it. How do we end it? We have to get out, right? Get out. And we say based on C, right? So we say if C is equal to 1, C is I just plus equal 1. Yeah, if C is equal to 1, I just plus equal 1. If C is not, If c is larger than 1, then I need to add something more. Right? Basically, it's the same thing. We have to do this again. All right. So we get out char I shall equal to this. If, right, it should be if c is larger than 1, then we do this. And then we do this. And then we do this. And then we'll pass. In fact, I think we'll pass. Probably pass everything. Oh, we still have something wrong. Which one? The first one? How is that possible? Oh, the same thing here. You didn't forget. If c is larger than 1. There we go. If c is larger than 1. I screw this. Let's do this. J. Okay. While j is smaller than len chars. And we just do j plus equal 1. There we go. We tried this, we tried this, we tried this. Have you tried a test case with all repeating? Like this. Have you also tried a test case, very ugly, like this? Thing looks good. Oh, I've done this before. Many times. Oh, got it in the first shot. That was good. Not particularly hard, but there are a few edge cases. There is one. There's one condition that I initially forgot to consider, which is when we iterate right through chars, we have to check. Right, we have to check the count again to decide. Oh, I saw. You cannot use it. It's required to be constant extra space. Otherwise, you can. I see. Yeah, you can accumulate. What's that? Accumulate? No. Group by. You can group by. Right? Otherwise, you can group by. So no. Yeah. Check the count again to decide whether we need to compress the last series of repeated characters. And that's about it. The things that we need to do. So when Oh yeah. Oh. Yeah, that's it. But this is much easier. Why? I won't say it's much easier. I think it's about the same. It has another while inside. I just do everything on the outside. Now I have another while here. Oh. Oh, we can do this. Ah, that's why rest have to plus equal to. Ah, that's all right. Why? Oh, that's a good point. That is a good point. That's a good point. But that's also a good point. Really? Yeah, they probably remove. I never see this. Really? Oh! It is true. What is this? Ah, that's a terrible, terrible test case. Really? So you're saying that if we do AAB, man. No way. No way. It's this. I got confused. Huh. Alright, that's the most I want to do on this one. Let's just move on. Put a marble in a bag. In bags. K bags, you're given a zero indexed integer, a weight, where weight I is the weight of the ith marble. You're also given the integer k. Divide the marbles into k bags according to the following rules. No bag is empty. If the ith marble and the jth marble are in a bag, then all marbles with an index between n and j should also be in that same bag. So that just means sub-array. If a bag consists of all the marbles with an index from I to j inclusively, then the cost of the bag is the front and end. The score after distributing the marbles is the sum of the costs of all the bags. Turn the difference between the maximum and the minimum scores among marble distributions. The maximum and minimum results in a minimum cost of 1 and 1 plus 1 plus 3, 5 plus 1. K is 2 into k bags, so no bag is empty, so it has to be okay. So it's just like splitting, right? So it's splitting the array into k subarrays, and we want to maximize the sum of the beginning and end of the subarray. We want to maximize that, and we want to minimize that. So we want to find the max and min, right? Find the max and min. Interesting. So how do you find the max given a subarray, right? So we need to divide to however many. So we can do, saying the maximum. So if we have the maximum of the remaining from this to the end, if I have the maximum of this, a maximum of this, maximum of this, that looks to me to be O(n) squared. Right? It just means if I have the maximum of this, of the front, right? If I have the maximum of this, I know the maximum. And yeah, but for you, it's, it's O(n) k. O(n) times k. That looks very expensive to me. That looks very expensive to me. Yeah, because like we can say from I to the end with j number of partitions. I want to find its maximum, right? And then I say if the first partition is 1, what is the maximum of this? And the first partition is 2, what is the maximum for partition is 3, all the way down, right? So yeah, and it has to go through, yeah, it's O(n) k, and it's never gonna pass, and I have to do O(n) k twice, right? Oh, is there a better way? I mean, we want to find a maximum, we find a minimum, and it's only associated with the ends of the subarray. So what if we look for the smallest? We get a list of all the unique values, right? You have a map, a dictionary. So in this question, we have 1 at the position 0 to 3. And we have 3 at position 1, and 5 at position 2, right? So to get 2 partitions, right? 2 partitions, we need 4, right? We need 4. We need to find 4 values. So basically, we're asking, is it possible to find 4 minimum values among all these things? Well, the minimum values, and we should also realize that things can be by itself, right? Things can be by itself. If we have, in this case, 4, right? If the minimum value appears 4 times, then we already have it. We just get the 4 minimum values, and then we're done with it, right? And then we're done with it. Plus, another thing to know is whatever you do, the front and end will always be in there. So in this case, the front and end is already done, right? So you cannot avoid the 1 and 1. And the difference, the 1 and 1 will be cancelled, right? So essentially, you are saying I have k partitions, and each partition has 2 values we need to consider, but we need to minus 2. So that is the total number we need to find, right? Total number we need to find. And in this case, so the front and end is not in the consideration, right? It's not in the consideration. And now we need to find two values. But actually the front and end still are in the consideration. They're still in the consideration. No, they are still in the consideration because we can take them once, right? Okay, so now everything like we put it down, right? We put it down. It has to take the neighbors, right? It has to take the neighbors. So basically, the groups that we have is, in the first is 1, 3, right? 3, 5, and 5, 1. That's the groups we can take. And to get 2, we need 1 partition. Like we slice it down once. So we just need to pick one of them, right? That can give me the maximum value. Well, 3, 5 gives me the maximum value. 1, 3 gave me the lowest value. So the answer is 8 minus 4 is 4, right? Okay. So what are you saying is you give me this, we're gonna produce a array that is the combination of every two, right? And then you're saying that we have different ways of producing, right? What if like k equals 3? If k is equal to 3, then we need to slice down twice, right? We need to slice twice. Now the question is, which 2 we need to slice that will give us the maximum value? We just need to find the top 2, which means we just sort it. Let's see if this one works. It might. Does it work of this one? Well, we need 2, so we need 1 slice. This is only having 1 slice, so yeah, this one works as well. So what we're doing is we're going to create a new thing, which is we can call it I would call it temp. It's very imaginative, right? Then we just say temp. Oh, okay. Can do this, right? And we say weights I, right, plus weights I minus 1. And we can sort it, right? Sort it, this whole thing. Okay. Then we shall return sum of temp, right? K minus 1. So minus k plus 1 to the end, right? Minus 1. And this minus sum temp, the first k. No, that is the first k, but we want a first k minus 1. Okay. Let's see. It should be 4. This is 0. weights. Okay. Put marbles. Weights. Okay. Okay, this one works. Are you gonna... How about 1? Let's try 1. Yeah, 1 works. Okay, we can try... Oh, well, we can try anything. I don't know which K you want to do. 5. Oh, looks promising enough. Let's try this. Ew. All right. So it's not 100% correct. I should have checked first. That was the answer. Expected 0. What? What type of nonsense is this? Oh, 1. One. Partition is 1. Partition is 1. How is this not equal to 0? What? K is 1. K is 1. This is bonkers. You're telling me this is... No way. K minus 1 is 0. Minus is... Huh. Huh. Seriously. Seriously. Minus 0 to the end is everything. Dude. 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 Minus 0. Okay, minus 1 is the last one. Minus 0. No, minus 0. Minus 1 to the end is this. Minus 0. Oh, that is because it's the same as 0 to the end. It makes sense, right? It's a 0 to the end. Is there a smarter way to handle this? Should be nothing. All right, so we cannot use a minus. Well, we can use len temp, right? Minus 1. Minus k. How many? Minus k plus 1. How about this? There we go. That's good. So we're gonna use this then. Well, if this is really in the competition, that would be very, very disappointing. So you basically already got it, right? You basically already got it, and just tiny small mistake. Yeah, right. You basically got it, but you know. Well, what's the thought process? The thought process is to get k subarrays out of weights. We need to slice it k minus 1 times, right? Each slice produces, right? Each slice produces two neighbors, right? Two neighbors which belong to the end of the previous subarray and the start of the next subarray. Thus, the score of a partition is the sum of all neighbors after the slicing plus the first and last value in weights. Right. Since the first and last values exist in both the max and min partition, they will be cancelled, right? Thus, we just need to find the max partition, the sum, right? The sum of all neighbors in the max partition and that of the main partition. Since the scores are only associated with the neighbors, and we can find the sum of all neighbors, sort them, and easily obtain the last k minus 1 elements as the max, right, as the largest possible, the sum, right, of the last as the max score and the sum of the first k minus 1 elements as the mean score. One thing to pay attention to is that if we use negative indexing to find the last k minus 1 elements, we will be bitten if k equal to 1. Thus, yeah, just O and log n plus k. This is k. This is O and log n. That's not too bad, huh? Not too bad. I said the D should be here. Quick select. Pairwise. What the hell is pairwise? Oh my god, I have something called pairwise. Oh lord. Pairwise. Gosh. Huh. N largest and smallest. Wait, this has this? Oh my god. Oh. Nth element. Mm. Alright, this pairwise. Yeah, I don't like the unquick select, that's not unnecessary. So, Lee 215 offers a solution based on priority queue, which is faster and uses some some built-in functions. Python. It looks like magic. So import iter-tools, import heap queue. All right. So temp shall equal to iter-tools dot pairwise. Jesus, how did you even figure this out? Weights. And I will return. I don't know if I need to turn that into a list. I will just return sum something minus sum something. We can do heap q dot n largest temp minus heap q dot n smallest. Maybe we need to do because I already consumed it. So maybe it's iterable. This is not iterable. So we have to do a list. N largest. Oh, I forgot the n. Wait, what's n largest? Missing one. N largest. N and iterable. So k minus 1. K minus 1. Where? Unsupported. For int and tuple. What? What do you return? N largest. What did I do? Don't know. Wait, hold on. Temp is right. Oh, you need to sum this. Oh, what's the key? So is pairwise has a key to it? Huh. So we're going to do the sum here. Okay, so it'll be like this. For W1, W2 in and W1 plus W2. That's not how he does it? Oh, it is. It is. He writes everything so short, so he kind of forgot. Man, it's good. No, it's slower, but it's fine. Doesn't matter. All right, that will be it for today. Yeah, wake up. This is actually not that hard. I will see you guys tomorrow then for this.